Following on from your study of total drag, we can examine the relationship between thrust, drag and power. You have already seen that drag in certain circumstances can also be referred to as thrust required, and you will see that a similar relationship exists with power required. They are both important airframe considerations. Although pilots tend to use the word power when discussing aircraft handling, quite often it is the case that they should be referring to thrust. Thrust is a force, a push or a pull, which opposes drag, but power is a rate of doing work. Power, then, is work over time, and work equals force times distance. So power must be force times distance over time. The force we are concerned with here is drag. Distance over time is speed, and the only true speed is the speed of the aircraft through the air, true airspeed, or TAS. We can thus rewrite the equation to read power required equals drag times TAS. If an aircraft climbs at a constant indicated airspeed, drag will remain constant, but TAS will be increasing, so power required will increase. As stated in the first part of the lesson, power is a rate of doing work, and so we must consider power required, since when the aircraft is climbing, work is being done to raise it to a higher altitude. Logically, the maximum work can be done on the aircraft in the minimum time, when the power available from the engine or engines is greatest, and the power required by the airframe is least. For easy reference, keep in mind the definition that power is a rate of doing work, and associate the words power and rate. For example, the minimum rate of descent is achieved when the aircraft is flown at the minimum power required speed, known as VMP, or min power speed. These considerations and other associated factors are covered in detail in the lessons on aircraft performance and flight mechanics. The diagrams on the screen represent data for one particular aircraft in level flight at one weight, and at sea level where IAS equals TAS. Starting with a curve for drag or thrust required against TAS. The graph for power required is constructed by multiplying each value of drag by the appropriate TAS and converting it to kilowatts. Note that the min power speed, an IAS, is lower than min drag speed. The effect of a change in altitude for an aircraft flying at min drag speed would be that its drag would not change, VMD being an IAS. However, the aircraft's TAS would be increasing, and since the power required would also be increasing in proportion, the ratio of TAS to power required is unaffected, and VMP will remain a lower speed than VMD. The information in this lesson is mainly concerned with performance, especially the relationship between minimum power speed and minimum drag speed, which is of importance when considering rates and angles of descent in a steady glide, which is covered elsewhere in the syllabus, in Chapter 12 of the OAA Principles of Flight book. A summary of the salient points from this series of lessons on drag follows in the next lesson.